Hi everyone. I'm Shubham. I'm one of the co-founders and CTO at a company called OLake. It's basically a product, not a company. So what we are doing right now is our vision is to help people adopt Iceberg, and we have seen a lot of people facing a lot of challenges in the last 8 months. We have done 150 plus discoveries, and we have seen a lot of people facing challenges in moving their data into Iceberg, maintaining Iceberg, and all of that. So a quick thing about me is I've been a data engineer for the last 9 years. Worked in Japan, India, Singapore. So I would like to talk about three problems. The first problem is scale. So when it comes to like the existing EL solutions, extract and load solutions, they're really good for the scale when it comes to like GBs to TBs. And especially if you see the tools like Fivetran and Airbyte, they're almost like they're good to cater to like half a terabyte to a terabyte, per month per customer. This is like real statistics. But what the enterprise who are trying to adopt to Iceberg is looking at terabytes to petabytes, right? And there we see a huge gap. Especially this comes when we are trying to use the managed tools, right? All of these managed tools are kind of warehouse centric. They have been designed like a decade back, and they've always assumed that there is a process which is running behind and which is doing the compactions and optimizations continuously as you ingest the data, right? Apart from that, like the all of these sources are pretty generic. The tools are pretty generic. They have M sources and N destinations, so they are not able to like optimize for one specific destinations, which is in our case Iceberg. And we strongly believe that Iceberg is going to be the de facto storage format after like maybe a couple of years, right? Everything would be on Iceberg. So, and typically these high volume sources that we see are databases, Kafka events, and S3, which is storing a huge amount of data sets. And the second problem that we see is the Iceberg adoption overall. Like this is a generic problem that we came to the conclusion after doing on tons of discoveries. Like one of the problems that a lot of people they like when we talk to enterprises, early enterprises, they have is it's not that they're not familiar with what the like benefits of Iceberg, but they're scared of adopting to Iceberg because it's kind of like the ecosystem is a little fragmented right now. There are tons of tools to do each of the steps. There is a lot of lack of knowledge, and this is pretty surprising. Like when we talk to a lot of data engineering teams, they almost among like 150 people that we have talked to who were on some legacy stack or some warehouse, only 15 to 20% of them are actually looking towards moving towards Iceberg, right? And this does not include the companies which are already on Iceberg. So, and that's a result of lack of knowledge around Iceberg. Still, a lot of data engineering teams are not sure on how to get the managed Iceberg tables. And also, for example, in Databricks, they are like a fully managed end-to-end solution for Delta. But in Iceberg, things are still evolving, and where the people feel like if they mess it up, they have to have a backup like a big company which is managing everything, right? Iceberg as an ecosystem, as I mentioned, has a couple of tools to ingest the data, a couple of tools to observe and compact and optimize, a couple of tools for the catalog, and a couple of tools for the RBAC or data governance. Apart from this, if you try to build the pipeline yourself when it comes to ingestion, you can build it using Spark, Flink, Debezium, Kafka. But again, all of this comes with like a heavy engineering overhead. You need to go extra mile to partition, to order, the schema evolution, data type changes and filtering. And also table optimization is something that we have already seen a lot of talks around, right? So, and problem number three, that this is something we have talked to a lot of banks, and banks and the legacy companies which have been running the data platforms for the last 20 years. They have a lot of data in Hive plus Spark, Parquet kind of ecosystem, and for them they have petabytes of data sitting in there, and they have to migrate to Iceberg because of the obvious benefits. But I think the points that they're getting stuck is they don't want to do a copy migration. What they want to do is the data is there. They want to sort of generate a metadata layer on top of this and just do a seamless no copy or no duplicate migration, right? And like once we generate the Iceberg compatible metadata, we migrate all of our workloads to Iceberg and then cut off the Hive layer that is running. And it has its benefits, like if you do this kind of migration, the query performance in some cases has seen improving like by 2 to 3 times because of all the Iceberg metadata, the partitioning and the all the other things. So these are the 3 problems that we have seen people facing when they're trying to move to Iceberg. So an ideal tool for Iceberg, if I think about it from ground up, like if I have to redesign it starting today, it has to have a really, really high throughput, because there is practically no limit on how big of a data that we can write to S3. And also because Iceberg is catering to really high data, like terabytes to petabytes, it has to read from these sources really fast and dump it into the Iceberg super fast, right? It has to be really lightweight. If we can avoid Spark, Debezium, Kafka, and just create a tool which is focused on just Iceberg ingestion, that would be awesome. Apart from this, like if I just talk about databases, like it has to have full load, cursor-based incremental, and CDC-based strategies to get that database data into Iceberg. And apart from that, it has to support all the latest Iceberg specs and catalogs, like geospatial data types and variant ones. Apart from that, like scheme evolution, table evolution, like that's one of the features that a lot of people have asked us to add. So scheme evolution, like if you add a new column, if you add a new table, it has to do the first historical snapshot first and then load the incremental data later. So all of this, it has to automatically handle. And apart from that, because the data that we are syncing is in terabytes to petabytes, it has to be resumable. If you're doing a full load or the historical load of the data and it fails halfway, it has to resume from that point, because you're not going to load a terabyte table again, right? So with this, keeping this in mind, what we have realized is, especially when it comes to databases, we have to split the big tables into smaller chunks and get that data parallelly into the Iceberg. So what we are doing here is, like imagine if the table has 10 terabytes of data, we are splitting the table into chunks of, let's say, 15 GB, 20 GB, and we are pulling that data and dumping it into the Iceberg parallelly. So this gives a really great boost for the like the amount of data that you're syncing. So we have done a lot of research, and for each of these databases, there are different strategies to split the data. Especially for MongoDB kind of a database, there is a split vector, bucket, auto, and timestamp. And MySQL, Postgres, again, like CDID is one of the popular ones. Apart from that, like when we pull this data from the chunks shouldn't be so small that if you're creating really small files, and chunks should be really optimally designed so that the files that you're creating are around 250 to 500 MBs, right? So you don't have to trigger one more compaction just to basically compact the full load of the data. And then finally, like while you're doing a huge sync, like huge terabyte level sync, you need to have some level of watermarking so that your CDC doesn't bloat. And if your CDC bloats, like basically your database stops working. So we need to have like a temporary Iceberg table where we are storing all the CDC while we were doing your full load. And then after the full load is done, we can apply the CDC. So wall is it's lightweight. Wall in case of Postgres, but again all the other CDC formats like binlog and oplogs, right? And then finally, a resumable full load, which is I have already talked about. And for the Apache Iceberg as destinations, this is something we have been thinking and doing a lot of innovation around. So like first things first, like we are writing into Iceberg using Arrow, and Arrow-based writes are really fast because you are storing the data into Arrow and then dumping directly into the Parquet and then committing it. So for the append-only kind of a use cases, we write parallelly and commit sequentially. For CDC upserts kind of a use cases, we basically, again, for some CDC sources, it's not possible to stream parallelly, like pull parallelly, but you can write parallelly, right? And Kafka kind of a sources, we can have multiple parallel writes per partitions, right? Apart from this, like this is one of the cool features that we have been, we have in our roadmap, which is while you're writing the data into Iceberg, how about you do a lightweight compactions? Imagine if you're streaming a CDC which is creating like KBs or a couple of single-digit MB files, right? And while you're writing it, can you do a lightweight compaction? Because having such a small files of CDC, it's going to be a mess. Your query performance will be really bad downstream, right? So we are also like, we are thinking of merging these KBs and MBs CDC files into like a medium level file, which is going to be of couple of, a little bigger than KBs and single digit MBs, right? So with this, you can delay the main compaction or the major compaction by some time, and which will give you a lot of cost saving, because the more you run the bigger compaction, the more you spend. Apart from that, guaranteed like exactly once delivery is something we all of us want. We don't want to kind of deduplicate the data after we ingest. So with this, we have been creating a tool called OLake, considering all of these points. And OLake is basically fastest way to get your data from sources like databases and Kafka into Iceberg. And with this, this is an open source tool, fully written from scratch in Golang. And we support databases like Postgres, MongoDB, MySQL, Oracle. And we also have Kafka connector coming soon. This project is, we have launched it 6 months back, and we have got a good traction on this. So we have just launched the V0 2 weeks before, and this is the version with a UI and a kind of orchestration. Also, the Helm chart is coming soon, so you should be able to deploy it on a Kubernetes so that you can scale it horizontally. And for the Hive to Iceberg migration problem that I have mentioned, so we are also planning to create a small product sideways, which can help people to generate this metadata layer on top of the Hive, and also AI plus some level of human in the loop kind of thing to migrate your workloads from Hive to Iceberg, right? But again, this is in a planning phase. We are looking for design partners for this. So with all of this, we have been working for last 6 months to create this and just launched the V0. The numbers look amazing. We have about Iceberg Go plus Arrow kind of a writer. We were able to get to like a 250K rows per second ingested into Iceberg. And this is for the NYC taxi dataset. We loaded about 4 billion rows. And apart from that, like Iceberg Java writer for OLake, it was around 46,000 RPS. Compared to the other tools in the industry like Fivetran, Debezium, S3, we were almost able to exceed or match the tools. Like, for example, Fivetran here, as you can see. And this is the cost of running this. As we are open source, it's pretty less, because you are running it on a single machine as of now. But for tools like this, you will have to spend per row synced. So that gets really expensive. Right now you see free here because Fivetran charges you based on monthly active rows after the full load, the CDC rows, right? So yeah, that's it. And apart from that, future roadmap looks like a lot of observability features coming in, alerts on failures, a lot of heart beating kind of a mechanism similar to Debezium, because again, it avoids the CDC bloat. We have been requested to add a lot of filtering features when it comes to the data. So let's say if you want to skip the data before 2 years or 3 years, you can just simply load the data after that. And again, partition evolution is something that we are looking at. We are also looking at some level of query optimization by dumping the data into specific clusters, so you don't have to do a lot of optimization later onwards. So yeah, again, we are contributing it back to the community as well. We are contributing to Iceberg Go. I don't see Matt, but Matt is helping us to contribute. We have been raising the partitioning PR soon in the Iceberg Go. We have also been trying to add the missing catalog supports and also equality deletes for Iceberg Go as a project. And yeah, I mean, I would like all of you who are looking to migrate their data from all of these sources to Iceberg, please give us a star. We are really focused on Iceberg and making your data ingestion really fast. So yeah, we have gotten a good traction. Like the red line that you see here is us. In just 5 months of launching, we reached around 950 stars now. Yeah, that's it. You can follow the repo here. You can also see the docs. We are fully open source, Apache licensed. I'm up for any questions. I just have 1 minute left. Yeah.
All right, questions?
Questions?
Whoever asks a question gets an extra bottle of beer.
Hey, thanks for the presentation, really good. Quick question. So you mentioned that you power the full the intensive loading. So what kind of a performance impact on the target side? Meaning, is you have to close the shop as a green zone to when your injections happens, because there's Iceberg itself is really bad on the performance when the big data got hammered by the injections. So you can open, doesn't matter how much parallelism you can, but you have to think about maybe you need a green zone for that, right? So I don't know, it's what kind of consideration for that?
So I'm assuming like if you mean that if you're ingesting too many things in parallel, like it would create too many small files and
Meaning is maybe you need some green zone, or that's you take care of that. Meaning sometimes.
As I mentioned, we usually take care of that. Like when you're doing a full load of the data or historical load of the data, we make sure the chunks are so big enough that we don't create like a MBs or KBs of files. We usually try to size the files around 256 to 512.
You do some optimization.
Yes, we definitely do some optimizations, and like we create the files first, and then only after the whole chunk is loaded, then we commit. So that's how it works.
Cool. Second question.
Yeah.
You mentioned this full load resuming process is very good, because when you have a big data, very difficult to start from beginning, right? So now, what kind of methodology you use? Because most time you want to find the unit for work. For example, you have older billing, and one order have multiple billing, one billing have multiple invoice, more invoice have multiple payment. So you want to find the unit of work, then you do logically to do them. So when you have breakpoint, you know where's your breakpoint. And whatever you load is good. So do you handle that way?
I'm not sure if I understood it correctly, but I'll tell you how we do it, right? As I mentioned, like imagine if a table is broken into 1,000 chunks. And if we have already loaded like 500 chunks, then we'll only load the remaining 500 chunks. And usually like all the data which is coming in right now, right? We basically load it as a part of a watermarking. So we load it into a temporary table, the CDC data, but all the previous data we just load it like using chunks. We make it resumable using chunks.
You just tag them physically, so you don't care about the internal logic.
Yes, we don't. We cannot care about the internal data. Yeah.
Okay, I got it. Thank you. Yeah.
Yeah.
Cool. Thank you. Great presentation and great project. One quick question on the parallel processing. So how do you handle like write conflicts across like different parallel workers for your writing? And like,
I think so. What we do is for let's say when we are doing the full load or the historical load, we basically write parallelly and then we commit sequentially. So we have that concurrency control implemented. For the CDC kind of cases, anyway, for the CDC you have to read sequentially and you have to write for different tables. So we cannot make concurrent in that, right? And for the Kafka kind of thing, we make it like again similar to the append. We make it parallel for the partition, and then we commit sequentially. So that's how we do it. Like major amount of time is taken into writes. It's not the commits, right? So usually like while committing, we take a pause and then we commit each of these writes sequentially.
gotcha. Yep. Thanks.